In this tutorial, we're going to look at point cloud and mesh segmentation. This tutorial is valid for VRGS 3.0 builds 25 and above. Right, the first thing we need to do is load a data set, which I've already done here, and this is a point cloud derived from LiDAR data. We need to generate some attributes. There are already some attributes in here, so the intensity, the red, green and blue color channels, but I'm just going to right click on the point cloud, go to attributes, tensor analysis. I'm going to set the sphere radius down to 15 centimeters, create all of the attributes and click OK. Now this is going to take a few minutes for the tensor analysis to run. So we'll come back when that has completed. So the tensor analysis is coming to completion. It's taken about 5 minutes for this to run. So it's one of those cases where you might have to go away and take a break while it's running. And we've generated all of these new attributes. The attributes we are most concerned with will be the dip. So this is the surface dip, not the dip of the beds. The direction of dip of the surface and coplanarity. So coplanarity is how flat the surface is. If we've got our charts tab selected, if you don't see the histogram like this, you can just make sure you've got that button clicked, which makes this display visible. We can drag the filter bars so we can better use the color scale. And now I've got that, I'm just going to go into transforms on coplanarity and clamp the data to the filter. And then that gives us a better use of our color scale and a stretched histogram. Now we can see the different planar facets in our data set. So there's obviously some here, might be one there as well. To classify these, we're going to go to Windows and bring up a stereonet window. Use the side-by-side view. The stereonet window works independently of the 3D window, so we have to switch on the point cloud for the stereonet window as well. And once we've done that, we can show some contours. Now the contours are getting the dip and dip direction data or dip and azimuth data from the attribute in the currently visualized data set. So it looks for attributes with the names dip and azimuth, and if it finds them, it uses those to plot the data from the stereonet. We can switch to a logarithmic scale on the stereonet to give us some more detail, and if we've got the stereonet window selected, go to properties and display options, we get some extended display options for the stereonet view, and I can change the number of contours to 50, which gives us a little bit more information in the stereonet. Now, we want to know where, for example, this planar surface lies on the stereonet. So I'm going to go to Edit and then select the circle. And nothing's happened. What we have to do is make sure that our point cloud is made active. And once the point cloud is active, we should, on the stereonet window, be able to see where these vertices lie. I have to do this, I have to make sure that for the stereonet, poles is switched on, and now we can see where those points selected there lie on the stereonet. So we need to make sure that the point cloud is made active and that poles is selected from the stereonet display options, otherwise these don't show. It's good to keep them switched off, mainly because it is quite a lot of data and can slow down the visualization on the stereonet. Right, we know where they lie now, so I'm going to use the select tool here, and I can select that part and then use down the control key for an additive select. Select that part, and from our model, all of the vertices that lie within those positions have been selected. I can then go to point clouds. To make the point cloud menu active, we need to make sure the 3D window is active, because the point cloud ribbon bar is tied to the 3D view. We're going to create a new fasces map. It's not fasces, but it's just the descriptions that VRGS uses. And then we're going to create a new item to go within it. So it's a new fasces dialog box, but I'm going to call this fracture set 1. Now, OK that. And then I've got this button here, which is apply to selected vertices. So it will classify this attribute using this parameter from the selected vertices. And if I switch on my fasces map now, should be able to see those vertices have been classified. Let's go back to our coplanarity attribute, and we can find some other surfaces. So perhaps we should look at some surfaces. Let's go back to move mode. Let's identify another flat surface. So we've got ones here as well. So let's try those. So we're going to go to edit, see where those lie, back to the stereonet window, switch the poles on, and they're falling. That one's falling around in this area here. So I actually know from looking at this data that there's another fracture set that lies here across to this side of the stereonet. So we'll select those. So I'm going to do a elliptical select, center it on that peak, and then do the same thing over on this side with the control to do the additive select, and maybe I'll make that a little bit bigger. So we've done additive select on those. Now I can go back to point clouds, make sure the 3D window is active, create a new parameter, so fs2, add those, and we should be able to see those coming up in the fasces map now, and it has selected. I can quickly go to my charts tab and reset the filters on that fasces attribute, because the filter would have set to the first data that was added to that, and then subsequently we've added a different fracture set, so we need to reset the filter. So now we can see this data set, this fasces map parameter has been classified into the two groups. We'll go back to coplanarity, and there's another fracture set which I happen to know lies on this area here. So I'm just going to go straight to my stereonet. I'm going to go back to elliptical select and select that one, point clouds, make the 3D window active. Let's call this FS3, apply it, and now we should have a fasces map. Let's reset the filter with 3 different orientations selected. So we're just about seeing them selected in there. There they are. So obviously it's picking up a bit of noise in here, so we could modify the way in which selected them to reduce that noise. But we've got our 3 main fracture sets selected. We can generate a bespoke color scale for this attribute that we've just generated. So if we go to our collections tab and open up the fasces group, we're going to go create color map, and we'll find a color ramp has been defined in the group there. So we can look at the color ramp's properties. I'm going to change this. Actually, no, that's all right. We can leave that as it is. Don't need to change any of those parameters. I'm going to go back to my fasces map here and say I'm going to change this to use that Fashi's color ramp, and then I should be able to go to my charts. If your chart isn't displaying correctly, what you can do is go select your attribute, go to your properties and click this button here, which is update object, which makes sure that all of the values for the current object are updated correctly. And now we can see we've got our different classifications. We've got 0, which is the background group, and then our 3 different fracture sets which we've defined. Those colors should relate to what we see in here, so I can change this to say a yellow, and I should be able to go back to my charts and see it updated in there. If it hasn't updated in the stereonet window, sorry, in the 3D window, you can just switch the Fashi's map off and back on again, and it will force the color map to update. And there we have a very simple and quick way of classifying your fracture data using the stereonet.